There are lots of things which we know about universe, but there are much more than that which we do not know about actual universe. So understanding the existence and makeup of a mysterious substance called dark matter is one of the leading challenges which scientists faces today. In this episode of Knowell series, we will be talking about this dark matter thing, and we will tell you exactly how it is important for us to study and important for us to actually know about it. So let's start with some basic theories and some basic understanding of dark matter. So there are lots of theories about this particular dark matter, but the understanding true nature of this dark matter is still being unknown. And why it's unknown? Because the greatest challenge for studying dark matter is that we cannot see it. So how exactly scientists uses the techniques to observe this particular dark substance, or kind of like predict this substance in space, so that they can understand it and get more information from it. So there are lots of theories available, but in this episode we will be talking about the most genuine and most trusted theories which can actually be true. So let's start with basic informations of dark matter. When we look up into the night sky, we notice that it is filled with thousands of stars. These bright celestial bodies include planets in our solar system, stars in our galaxy, and entire galaxies that are far or far more away from us. These objects make up all the light emitting matter in the universe. With the help of different kind of telescopes, we can observe these celestial bodies through the light they radiate. All telescopes work by detecting lights in the electromagnetic spectrum, from visible light to X-rays emitted by these celestial bodies. So that's how they work actually. Scientists use the various wavelengths of detected light to determine key information about our universe's celestial bodies, such as distance, age, size, and shape. They can even use some of this information to understand the laws of the universe. Yet there is matter in universe that does not emit light in any part of the electromagnetic spectrum, which means that we cannot observe it with our telescopes. And this matter is known as dark matter. This unique property makes it impossible to observe these types of matter, so scientists called it dark matter. And that's where the actual name came into game. Some scientists, specifically astrophysicists, spends a great deal of time generating theories about what dark matter could be. Scientists know that dark matter does not emit light from any part of the electromagnetic spectrum, but dark matter has been observed to be influenced by gravity, and astrophysicists are still unsure what exactly dark matter is. But the thing here is that they actually know what dark matter is not. So by observing the way it behaves compared to other materials, they know exactly what dark matter is. We know that dark matter makes up kind of like 80% of the total mass of galaxies. This means that there is 4 times more dark matter compared to regular matter. If dark matter is so difficult to observe, why do scientists believe it actually exists? So that questions bring us to 3 main divisions of this particular episode. We will be talking about these 3 divisions, and we will provide you complete information about dark matter in 3 particular theories. So this is the first section where we will be talking about movement of stars and relation of movement of stars with this dark matter. The first type of evidence supporting the existence of dark matter has to do with the way dark matter affects the movement of celestial bodies. In our solar system, almost all of the mass is in the Sun. The innermost planets like Mercury and Venus orbit the Sun the fastest. As the distance from the Sun increases, the speed at which planet moves decreases. This is because there is less gravitational pull from the Sun on planets which are farther out, and to keep from spiraling into or away from the Sun, they must move slower. We can apply a similar analogy of galaxies. If we assume that the bright part of galaxy source where most of the mass is, then most of the mass is near the center, and at the dim edge of galaxy there should not be much mass. Therefore, objects orbiting far from the center of galaxy should move slower than objects closer to the center, just like the planet in our solar system. To test this hypothesis, scientists recorded the incoming light from the distant spiral galaxy. And by the way, by talking about spiral galaxy, I am only talking about Milky Way. So Milky Way is basically also considered in a spiral galaxy. Anyways, they plotted the velocities of the stars versus their distances from the center of galaxies. Scientists discovered that the stars were not behaving in the way anticipated. They found that the stars farther away from the center were moving much faster than predicted. The only way this is possible is if there is more mass in the outer parts of galaxies than we can observe. The fact that we are unable to see this mass because it is not emitting light, which suggests the presence of dark matter, of course. So this was the small theory. Now let's move to next section, which is the mess up with calculation of galaxy mass. Back in 1933, Fritz Zwicky, a Swiss astronomer, was one of the most popular person for this particular dark matter because he first detected the presence of dark matter. He determined the mass of the coma cluster using two methods. One method used the velocity of the galaxies, which he determined by measuring shifts in the light they emitted. The second calculation method determined mass using the total brightness of cluster. In comparing the two resulting mass estimates, he found that the galaxy velocity measurement estimated that there is hundreds of times more mass in coma cluster than the brightness estimate prediction. Since the extra matter was not emitting light, he said, if this would be confirmed, we would get surprising result that dark matter is present in much greater amount than luminous matter. Very soon after, a similar result was obtained from the Virgo cluster of galaxies. However, measuring techniques at the time were not as precise as modern method, and the controversial nature of the result, that the universe is dominated by some kind of unknown dark matter, caused scientists to reject this hypothesis until almost 50 years later. Another research found out that dark matter actually bends the light. And that's where our third section starts. So this third area of evidence supporting the existence of dark matter comes from a study of bullet cluster, which is the name given to the two galaxies that recently collided. Astronomers have found a way to discover the mass of celestial objects like galaxy using a technique known as gravitational lensing. Gravitational lensing is based on the fact that the mass of an object influences the density of space around it. When light travels through this dense space, it bends. To make this clear, let us imagine a flat stretched sheet. The sheet represents space between no masses are near it. Now, imagine placing a bowling ball on the seat. We know that the seat will get pulled down by bowling ball. The ball would curve the seat in a similar manner to how masses curve space-time. When light passes near an object in space, it travels on the curved surface, which bends the light waves, and the larger the mass of the object becomes, the more the light bends. With the help of this theory, we can determine the mass of a celestial object by watching how much exactly the light from a star right behind it bends. Using gravitational lensing, scientists determine the total mass of bullet cluster, including the dark matter. Dark matter makes up about 63% of all the matter in the universe, which is very great. Indeed, our ability to understand dark matter will help us learn more about the universe, including details of the universe's origin and formation. Many experiments are being carried out around the world, including experiment at the Large Hadron Collider in Switzerland, to determine the nature of the tiny particles that can actually tell us about the conditions in which dark matter is formed. They did these experiments. Far more work needs to be done, but one thing is for certain, that there is a lot to look forward to in the fields of astrophysics and particle physics. I think that's it for today's episode. We will be making a separate episode for Q&A kind of. Like, we will be talking about some very popular questions and we will answer them, and we will try to give you the most efficient and most true and factful, trustable answer. So if you have any questions related to this particular topic, you can suggest us in comments, and we have picked some very popular questions from internet also. So that's it for today. I will meet you in main podcast. Thank you so much for listening to me.